Hello everyone, and thank you for attending our webinar today. I'm John Delaney and I lead on mobile services research for IDC in Europe. I'm joined today by Johan Arts of Equinix, who's a Senior Vice President in EMEA. Together we aim to help you understand the major new capabilities that 5G brings to mobile networks and the new things that those capabilities enable enterprises to do. I'll start by looking at what 5G can do, how 5G is already being applied by forward-looking enterprises, and how the scope and scale of those applications is set to develop over the next few years. I'll then hand over to Johan, who will explain how network architecture, resource location, and ecosystem access will each play an increasingly crucial role in enabling enterprises to get the most out of 5G. After that, we'll have some time to deal with any questions you may have about what we're presenting here today, or about 5G more generally. If you have a question, please type it into the Q&A box on screen at any time during the webinar. Q&A is also available, by the way, if you're watching this on demand. At the end of the session, we'd be very grateful if you could complete the feedback form. It's valuable for us to keep up the quality of our webcasts. Now, unlike previous mobile Gs, 5G will be rolled out in a series of phases, each of which will be associated with a distinct set of capabilities. The commercial 5G services that mobile operators started launching in 2019 bring the first phase of 5G capability, enhanced mobile broadband, to market. The next phases will emerge successively during the early years of the 2020s, each phase enabling new applications of the mobile network. We're now in phase 1 of 5G, enhanced mobile broadband, in which customers of the first commercial 5G services are experiencing data throughput rates of several hundred megabits per second. The 5G technology roadmap promises further enhancements that will eventually take 5G past the gigabit per second mark. With data rates in this range, the mobile network can support usage of high-volume applications such as streaming of high-definition video, real-time big data analytics, and sharing of high-resolution images such as MRI scans and engineering drawings. Phase 2 of 5G is ultra-reliable, low-latency communications. 5G will reduce the time a signal takes to travel from source to destination from the 50 to 100 milliseconds that are typical in 4G networks to 10 to 20 milliseconds, and eventually to single digits. This will enable the mobile network to support applications that have not previously been possible, things like online virtual reality, real-time automation, and remote command and control of things like construction site equipment, drone aircraft, and robots. A 4G mobile cell site typically has the capacity to support between 10,000 and 20,000 connected devices. In a world where most connected devices are smartphones, that's enough, but an increasing number of connected devices are not smartphones, but rather the sensors, actuators, and other devices that are used in Internet of Things applications. As the number of mobile connected IoT devices grows, the cell sites they connect to will need to handle many more connections than they can support today. So the third phase of 5G, massive machine-type communications, will take the connection capacity of cell sites into the 50 to 100,000 range, and then several hundreds of thousands. On top of these successive improvements in 5G capability, we'll see mobile operators develop network slicing. This will enable operators to create virtual networks for individual customers and individual applications that will deliver the required performance consistently and constantly, without being affected by what other customers and other applications do. Network slicing will therefore enable public mobile networks, for the first time, to support mission-critical connectivity and enterprise service level agreements. Now, I started researching 5G 6 years ago. A lot of the technical detail hadn't been decided at that time, of course, but a clear idea was already emerging of what 5G networks should be capable of. In essence, they're the capabilities I've just described, although there were some other targets that have fallen by the wayside, such as an order of magnitude improvement in device battery life. There was also a lot of discussion then, as there is now, about what 5G networks could be used for. So I thought it would be interesting to review some of my notes from that time and see what were the most widely discussed potential applications of 5G, and to review the progress that has been made in bringing them to reality. Of course, the most widely implemented applications of 5G that have been deployed so far have been those that take advantage of enhanced mobile broadband, high-volume data transmission applications such as broadcast quality video, high-resolution security surveillance, and diagnostic-grade medical imaging. This is also enabling a certain amount of telepractice to be put into place, whereby experts can apply their expertise in a wider range of situations without needing to be physically present. We're a long way from seeing surgeons being able to carry out procedures remotely, but we are already starting to see the emergence of 5G connected ambulances, for example, in which the paramedics can exchange diagnostic images with expert medical practitioners who can then give the paramedics sufficient guidance to allow triage and even treatment of the patient to begin before the ambulances reach the hospital. Low latency and high reliability are not yet available in operators' general 5G networks, but it is possible to implement those capabilities to some extent in specific localities and for specific customers. Thus, we're also seeing some implementation of remote command and control on 5G in applications such as autonomous vehicles operating in logistics company sites, and remote control of cranes and other equipment in seaports. Two other areas of 5G application that were widely discussed 5 years ago have not yet really emerged so far. The tactile internet, in which haptic feedback technology gives the sensation of touch at a distance, would be a big step forward in enabling applications such as remote medical practice. But today's 5G networks are still a long way from what would be needed to support the tactile internet. Another widely discussed application area, smart city infrastructure, is also not commonly implemented on today's 5G networks, but for a different reason. At present, the scale of smart city applications such as smart street lighting and waste management is well within the capabilities of 2G and 4G networks. It will be a few years before the number of smart city connected endpoints requires the massive machine-type communications use case of 5G. Some additional 5G applications have emerged that were not being widely discussed 6 years ago. Examples include cloud application usage, online VR, and one other, which is simpler in concept and which is gaining traction at a rapid rate among enterprises in some industry sectors. We'll come to that one shortly. As an example of the breadth and range of 5G applications, both now and during the coming few years, let's consider what's happening and what's in the pipeline in the manufacturing sector. Companies are using 5G to provide local area connectivity for personnel, vehicles, and IoT devices, with ultra-low latency and massive connection density where required, and with guaranteed network performance. The most common scenario is that 5G is used alongside existing site connectivity technologies at first, potentially replacing them altogether later on. Manufacturers can also use 5G to track products and components as they make their way around the production sites at various stages of the process. As well as location, it's also possible to track other conditions, such as temperature. Manufacturers can consider extending the tracking of products over 5G beyond production into shipment, both in transit and potentially after delivery for critical high-maintenance products, such as wind turbine blades. 5G can support process optimization, with continuous monitoring of activity in the whole factory, its workers, its plants, its inventory, and its products. A feedback loop can continuously gather data about process activity, analyze the data to identify areas that can be improved, and in some cases mediate the implementation of those improvements. With latency in the 10 millisecond range, 5G networks will be responsive enough to support command and control of manufacturing site equipment such as autonomous guided vehicles and mobile robots. The control could be carried out by human operators, by AI systems, or by a combination of both. A single center could carry out control at multiple sites. Through wearable devices such as AR glasses, 5G can guide workers in processes such as plant installation. Workers' physical abilities can also be augmented through 5G-controlled robots. They're sometimes called cobots, and they help workers with tasks that require more dexterity, strength, or endurance than humans can achieve. Now, the first of those manufacturing applications, site connectivity, is the one I referred to just now. the one that wasn't really being discussed 6 years ago, but that's now emerging as an important and fast-growing application of 5G. That's because 5G site connectivity can bring important benefits to enterprises in a range of different vertical sectors. In the energy sector, 5G can provide local area and wide area connectivity for personnel, vehicles, and IoT devices, with ultra-low latency and massive connection density where required, and with guaranteed network performance. 5G can also be used in exploration and extraction as a medium for controlling machines and robots, reducing or even eliminating the need for human personnel to be present in dangerous environments like deep mines and offshore drilling rigs. In entertainment and media, the extra capacity of 5G can enable operators of venues such as sports stadiums to provide all attendees with a good quality connection. 5G can also be used to provide and charge for innovative media services for attendees, such as AR-enhanced commentary, multi-angle playback, and interaction with music acts, sports clubs, and match officials. In sites in which public sector authorities are typically stakeholders, such as seaports and airports, 5G can increase operational efficiency and expand the range of services available to carriers of freight and passengers. In seaports, 5G can support applications such as real-time monitoring and analysis of environmental data, control of traffic flows, and control of site equipment such as cranes. In airports, 5G can support applications such as instant downloading of flight data when aircraft land, remote control of service equipment and vehicles, and AR-enhanced guidance for site service personnel. The operating premises of enterprises in the healthcare sector are constantly peopled by the public as well as by the enterprise's staff. Connectivity requirements there will therefore vary widely in terms of performance, reliability, and security. There may also be a requirement to charge some types of people for device connectivity. 5G can support both the capacity and the differential classes of service required. 5G can also be used to track staff, equipment, and inpatients, and to monitor the status of facilities on the premises itself, including publicly accessible facilities such as elevators, toilets, and car parks, and controlled access facilities, such as radiography rooms and operating theatres. The technologies used in mobile networks can offer enterprises several advantages over traditional enterprise networking technologies. These include increased flexibility, higher reliability, higher capacity, and a reduction in the number of access points required. As I previously mentioned, private cellular networks, both 4G and 5G, are emerging as a major area of opportunity. A growing number of private enterprise networks are both trialing and adopting cellular technology in sites such as manufacturing campuses, airports, seaports, and mines, and these private cellular networks are increasingly encompassing 5G. Private 5G networks play squarely into enterprises' objectives of reducing cost and improving productivity through automation, both of which are coming to the fore in response to the difficulties arising from the COVID-19 pandemic. As a result, both trials and commercial installations have been picking up pace through the first half of 2020. And here we list some of the new mobile private network deals that have been announced during this year so far. These enterprises are wasting no time in laying the groundwork for building competitive advantage into the 2020s. To get the most out of 5G networks, they need to take crucial decisions regarding network architecture, resource location, and ecosystem access. With that in mind, it's now my pleasure to hand you over to Johan Arts of Equinix, who will discuss those crucial issues in more detail. Over to you, Johan.
Thank you, John. And I'd like to start by introducing Equinix briefly. Our mission is to power and connect the digital world. The company was founded in 1998 in a way to serve neutral hubs where networks could connect in a time that the internet was growing and was looking to maximize performance in a neutral way. It's even what generated the name, equality, neutrality, internet exchange. Over time, our role has widened, and we now interconnect clouds and enterprises and networks and hyperscalers of many types. We believe that the connections of the future are going to be very important, and the change over to 5G will be a trigger for another set of requirements that are going to be important to depend on. 5G will set a new bar. Because at the moment that 5G makes available all these capabilities that John just laid out in terms of performance and latency, the rest of the ecosystem upon which application structures depend will also be required to operate at the same speed. So it makes for an interesting future. Let me start by recapping some of that. And 5G is not just a small step. It's really the step that would enable the enterprise side to start taking advantage. And John laid out those use cases in a nice way already. But it requires underpinnings that 5G provides in throughput, in connectivity, in latency to become more widely available. What I'd like to do now is to take you on a journey where we will inspect some of these use cases through a few lenses to see, are all the paths to value for 5G use cases equal, or are there some differentials? And what are some of the dependencies we have on other parts of the ecosystem so that I'm able to decide which are the better use cases for an organization to focus on? And we can cover the wide range that John already laid out, from those who are more immersed in video with high frequency moving of video, who are more focused on the robotics or any of the immersive experiences that John laid out. But this, when you look at it from a range of use cases, is a rather non-structured lineup. What we'd like to do is to categorize these use cases, and let me offer you a lens for that. First of all, in the first category we'd like to explore is those use cases who are more oriented towards an autonomous application of 5G, focused on a particular locale. John mentioned the example of equipping his stadium with 5G sensors to offer an enhanced user experience. In its simplest form, that kind of use case has no direct dependency on exchange with data outside of the site itself. And it makes it very different to gain and extract value from a use case if you would compare that to a more advanced use case. In the manufacturing industries, these could be examples where customers would deploy the typical 5G sensors in process automation or for asset monitoring and tracking. These are all very well-known use cases. And much of the decision cycles in these use cases depend on which sensors to acquire, how to install equipment, how to make it work from a local basis. And then many customers can hook that up with software and technology that already lives in the premises as it is. Important, but it will also not drive maximum value because the connectedness to other parts of our ecosystem can give additional value. What I'd also like to note is the interest that this area of 5G has started to spark with some of the hyperscalers. If you look at innovations that are being offered by Google with the Edge TPU, AWS with their Greengrass IoT structure, and Azure's stack Edge that's been offered in this area. These kind of announcements are very much focused on giving edge locations an ability to take advantage while, but not necessarily being connected to other parts of the infrastructure. So it's interesting to see that that as an environment is attracting the interest for investments independently of what the clouds do in their core infrastructure. But it may be very easy to imagine that once you go for more advanced use cases, you might want to take advantage of data that doesn't live on a local premise by itself. Imagine in asset performance that you may draw on performance benchmark data that may live on another part in another private cloud or on a public cloud. This will require your ecosystem to function slightly different and may put also demands on how you have organized for your remote cloud access. It is all about the system boundaries that you're implementing. And what you can also imagine that if the requirements go beyond an upload or download capability of static data, we are entering more directly into the domain of the hybrid cloud. And you can see that this is also an area that has attracted the interest of the cloud and the hyperscalers, and many developments have been announced in this area already. What we see is that when organizations move to this area, they start looking at application containerization and Kubernetes style technologies so that they can decide where to deploy their applications in what part of the stack. And the demands upon the end-to-end system become different as a consequence of that. This second category, we'd still like to place independently of what we consider the more advanced category, which aligns directly to some of the more fancy use cases that John laid out. What happens if you start exploiting video in real time? that doesn't reside in your locale, but that maybe have to be drawn from another source. One of the areas that will expect early adoption of high volume adoption in 5G is the gaming area. It's believed that in gaming, the introduction of 5G will lead to full-scale deployment of cloud gaming, where the rendering engines will not be local, but will be drawn directly from the cloud as well. And when we are speaking about the more advanced enterprise use cases, such as the augmentation of worker or the teleskills use case that John mentioned, where you're augmenting a worker with virtual reality or augmented reality capability, what if you have to draw those additional rendering engines from another location? This is where low latency across the entire chain becomes relevant. What we are seeing right now is that the rendering engines that are used to build Fortnite are also starting to be piloted for enterprise use cases like AR and VR. And it doesn't matter whether you take the Unreal Engine or a Unity engine, or if you're experiencing with the advanced technology from a player like NVIDIA. In all of these cases, you're no longer just dependent on what happens in a 5G deployed area, but you are dependent on a complex supply chain of information where you need to look at all of the weakest links. So let me walk you through and apply these different categories through a diagram that will be familiar to many of you, and let's talk about some of those limitations. If you are focused on the implementation of site connectivity, the fixed wireless example that John mentioned, basically all of those use cases where you have very limited dependency on cloud access or on high throughput data moves at very high speeds, then your system boundaries are relatively near. And it makes it relatively easy to control the scope of the project. So in a diagram like this, most of your effort will be focused on the last mile and where you're implementing inside its locale. But if you're moving to some of the more advanced use cases, where you may be interested in drawing data sets, benchmarking information, or algorithms from public cloud environments, suddenly your system boundary moves and the complexity of your system becomes factors more complicated. So what I think is interesting in this case is that the low latency, the high throughput, and the other capabilities of 5G suddenly have removed all the boundaries that existed in that last mile, and the bottleneck shifts to other parts of the end-to-end ecosystem. So as you are designing how to extract value from your 5G use cases, and your use cases do include these dependencies, it's very important that you understand these new boundaries and that you also work on removing obstacles further down the chain. And you can well imagine that if you go to the even more advanced use cases that I mentioned, with video, with AR and VR, that becomes even more relevant. And it's interesting to see how other developments in technology are starting to become relevant for extracting value out of your 5G implementation. In this diagram, we added those little triangles where we can reflect how organizations start moving compute away from just having it in the public clouds, but perhaps also by deploying edge nodes or deploying compute stacks as part of the 5G implementation, because perhaps they use more advanced 5G devices. This kind of a distributed architecture moves away from a classic concept of last mile and middle mile and backbone, and introduces other technologies that have its own development cycle, but through the combination of these technologies allow you to implement new use cases while taking care of the natural and engineering bottlenecks like the speed of light. So the implementation of 5G networks in this way can really become a foundational point in the implementation of a new distributed architecture altogether. And let's make this a little bit more practical. In today's use cases, even when you're deploying 5G at this moment in time, you typically have the handoff between your radio network and your data network happening somewhere inside the telecommunications network. What if you're moving this intersect point and you start making the interconnection from the mobile radio network to the data network inside one of those edge centers? You suddenly start to change the equation, and you become able to support an entirely software-defined architecture where you take advantage of some of the other capabilities of 5G, like the sliced networks, to offer an end-to-end private connectivity between the 5G device and whatever other resources you need to apply, whether those are on public clouds, inside your own domain, or inside private exchanges. And then you are going further than offering 5G capability on one side of the spectrum, but you also start offering advantages of security and control and the delivery of quality of service all along the line. As you start supporting 5G devices that may be with your equipment, that may live in the wild, and that may be going out on a very large distributed scale across the world, these become very interesting advantages for enterprises as they're also looking to take advantages of the 5G capabilities. On our side as Equinix, we are looking to play an active role in this ecosystem. And we have brought together some programs that help organizations take advantage of this in early stages. We already have, in many cases, mobile networks that are housed inside our network of data centers or that take advantage of our interconnection services. And we're bringing those together with technology partners that build equipment or devices or other supporting capability for the 5G network. And we're combining that with application providers that are managing these hybrid cloud stacks. And that's the way we can help clients, whether they're telecommunication operators or systems integrators or enterprises, to experiment with these various use cases. We're combining that with our mobile sales activation program that's been participated by many providers already, where we look to implement various flavors and various use cases in a way that value can be extracted in a practical way. And with that said, we hope to offer a path to value for those who also believe with us that 5G is going to change the world. So the recommendations that we have from our perspective is that 5G as a technology should not be looked at in isolation. You should categorize your 5G use cases for complexity and the data transfer rates that go with it to extract value, and then bring together your 5G initiatives with your strategies for cloud connectivity and edge computing initiatives. Because that way you can drive a proper understanding of your system boundaries, which is, in our view, a critical component for extracting value from the use cases you look to implement. And with that said, I complete my remarks, and I'd like to offer the control back to John so that we can take time for questions as they come from the audience. John?
Reached the point in our webinar where we can deal with some questions from the audience. And I'd like to start, if I may, with one for Johan. We talked a lot about manufacturing as a sector which is interested in deploying 5G during this session. Are you seeing interest in particular from some other sectors? And if so, which ones and what sort of applications are they interested in using 5G for?
Yes, we see an interest coming from a wide variety of sectors at this moment. And it's interesting to see that you can see different interest in these different categories. Some industries, like within public sector, we see that are taking the category 1 use cases, but they take them by design. For example, in the defense sector, they are interested in staying air-gapped and having 5G be applied in a way that nobody can see where the tanks are moving, nobody can see where the planes are, but are still looking to take advantage of the fixed wireless access and the basic site connectivity capability. So this is kind of against what we laid out for the enterprises, who in often cases will want to take advantage of the category 2 and category 3 and the interconnection, but that doesn't apply to all public sector subsectors. We also see a lot of interest in healthcare, where customers, the healthcare organizations, are looking for increased efficiency, and in collaboration with the innovation coming from the equipment manufacturers in that industry, are moving forward to implement cases as well. Sometimes powered or driven by the OEM side, but in actual fact also coming from the healthcare providers. Those are the 2 examples, but I could equally continue of some of the other industries where we see an interest in bringing those together, John. Okay.
Yeah, I must say I agree with you on particularly on the healthcare side. When in the research that I've been carrying out in this area, it's emerging as as a key beneficiary of some of the things that 5G can do, but importantly, some of the things that it can do now, as well as some of the things that 5G can do later on. So there's a clear path there for those applications to evolve. I wonder if it's, in the experience that you've had so far, particularly, I guess, through the proof of concept center that you mentioned in Dallas that you're running, have you got any points of best practice or good advice for companies who are wanting to start on this journey, or maybe they've started investigating what 5G can do but aren't really sure how to apply? Any sort of best practice emerging so far from that work?
What we see is that when the projects are becoming visible to us, a lot of emphasis goes to the infrastructure. What devices do I need? What sensors do I need? How do I hook it up?
Right.
And we think best practices in that is that before making those technical choices, that some good practices of defining what the project is for, what the value of the use case is, how to tie it back to a business objective. That's really one of the first practices, because we find that otherwise it's easy to get lost in the technical details, while it's unclear to get a business return out of it. And projects easily strand after the first small-scale pilot when those things are not clear. And that would be my first point of advice that we think is necessary. But how about you in this case, John? Because you also see a lot of projects. What would be a piece of good advice or best practice that you see in this case?
Yes, and you're right. It's something that I've been giving a lot of thought to. And I think I would say probably for a lot of enterprises, maybe the most important thing is patience. There's a lot of hype in the media about the revolutionary capabilities of 5G, the way it will transform industries and society even. It's being really hyped up. And meantime, what we've got at the moment in the public networks is a faster connection. And that's not something to be sneezed at. That's a technological achievement. But some of those transformative capabilities that are being hyped up so much at the moment, and particularly things like network slicing, where you can get guaranteed performance, those things are still in the pipeline. They're a year or two away. So I think the most important thing, from my perspective, is that, firstly, that enterprises need to understand that, and secondly, they need to be bearing it in mind when they're planning what to do with 5G. Don't expect yet to be able to have a completely reliable connection for controlling your drones, for example. 18 months, 2 years, maybe that will be the case, but probably will be the case. You'll have that, and certainly you should be planning for it, but don't have expectations that run too far in advance of reality. Listen to what the operators tell you in private about what their networks can do, rather than listening to what the media are telling you in public.
Oh, very interesting. And maybe to offer another thought on this is when the previous really fast period of momentum was when 3G was combined with the launch of the iPhone and the availability of the App Store. Those are really three components that built together gave the capability and the killer app that caused the disruption. And it wasn't just the connectivity or the bandwidth of 3G that did it. It was the combination of those three things. I think it's interesting to be on the watch for what will do that in the 5G space as well. And when you are looking for that, it's interesting to look for the disruptors. And this is the reason that I pointed out the investments that some of these hyperscalers are making. Because what I see is that a lot of people are focused on the OEM equipment vendors and people that make sensors and all the technical details. But it's interesting to explore the newfound architectures in IoT that the hyperscalers are building, and the way that they're looking at the problem. Because it's not oriented towards the device, it's more oriented towards the stack that they can build that can live in the wild, that takes advantage of that new 5G infrastructure, but that still is a partial enterprise stack, where they take advantage of all these elements like containerization of applications and the run anywhere part, but they're extending that from beyond enterprise IT fully into that widely scaled distributed environment of where these new applications will live. Now, that doesn't mean that all stacks, full stacks will live on all types of devices, but it becomes interesting to see how that in the future will disrupt through players who were not known in that field before. And I think that's something to keep an eye out for, because of their level of innovation and speed of innovation is really high, and is going to deliver a different way to solve the same problem.
Excellent. Thank you, Johan. And thank you to our audience today for your attention, for listening to us. That concludes our session. We've come to the end of the time that we have. My thanks again, once again to Johan for his contributions. And please do remember to fill in the feedback form when the session closes, because we really value your feedback. But for now, thank you and good day.